Okay. So once we distribute that 12 and then add the 1500, y equals 12x plus 300. Now, we're going to start getting a little pickier here. What variables did they ask you to use? And trust me, Chloe, your table's not the only one who did notice that. What variables are they asking us to use? C and P. So if you still want to start off with x and y, that's fine. Just kind of double check. So they want an equation for cost in terms of P, basically. So we're just going to rewrite this using those variables. Okay, but you guys are good. Now, what I really want to hear is what you guys thought about the slope. What does that slope of 12 mean?
You said in this equation, the slope, which is 12, is cost per person.
Awesome. That is a fantastic answer. Can you say that one more time a little bit louder?
In this equation, the slope, which is 12, is
The
the cost per person.
cost per person. You can say that a couple different ways. So for each additional person, the total cost increases by $12. A couple different ways that you could phrase that, but that's essentially getting to what the slope means in that problem. Awesome. Very good. All right. Let's flip it over. And again, please do not freak out on me. If you do not get kind of all the instructions on your calculator, if your calculator's giving you an error message, just kind of watch. Don't freak out on me. We will get it. If you need to come to AL, I will work with you on that calculator, but just promise me that you're not going to freak out if your calculator gives you an error. Okay? Just kind of follow along. I'm going to be doing everything up here as well. Okay? So the rule is don't freak out. All right. So what we're going to be looking at is what we call linear regression. Bless you. Basically, linear regression is taking a set of data, so you have that table of data, and we are going to fit a linear equation to that data. For many examples, that data will not be completely and truly linear, but we're going to model it with a linear equation. Okay, so sometimes you hear line of best fit or linear regression is kind of the same thing. So what we are going to do is we are going to look at this table. So apparently there is a relationship between the length of your femur, which and your height. Okay, so we have this set of data. It's asking us if it shows an exact linear relationship. An exact linear relationship. So let's look at this data real quick. You're increasing your x values by different amounts. You're increasing your y values by different amounts. It's hard to tell until we really get, it's kind of more of a pre-calc topic that we really get into. It's hard to tell from this table if that's an exact linear equation, okay? But we're going to find that out using our calculator in a little bit. What we're going to do is jump down here, and we are going to use our calculators to write the equation of the line of best fit, all right? So grab those calculators again. If you don't have one, just kind of follow along. The instructions that you are going to go through are all written here. So it says step 1 is to enter the data into 2 lists. So you are going to go to your button that says stat, which is right underneath delete. So hit that. And then it says in the directions, stat, and then go to edit. So edit is option number 1. So you're going to hit enter. And you can see that in my 2 lists, I already have some junk in there from who knows when. So if you have anything in there, just delete all of that. All right, then what you are going to do is you are going to enter the X values in your list 1. You are going to enter those Y values in your list 2, okay? And it's literally just typing the numbers and then hit enter to get down to the next row. So 40, 45, 32, 50, when you're done with that, just use your cursor to get over to L2 to enter those Y values. Those entered in. All right, after you get all of your data points entered in your list, then we are going to use the linear regression feature in the calculator to give us the equation of our line. So again, it tells you kind of the steps that you need to take. So go back to your stat button, which again is right underneath delete. So hit stat. Then we go over to calc. So scroll over with your cursor to go over to calc. And then it says option 4, and then it tells you what it says. So option 4, LINREG, basically linear regression, okay? So just scroll down there. Depending on what calculator you have, you might have to, on mine, you just hit enter. Some of the newer ones, you have to scroll down to where it says calculate and hit enter. So it just kind of depends on what calculator you have. And then you should get these 2 values. Okay, so you need to choose option 4 to enter. I don't like I said on yours, you have to scroll down where it says calculate and hit enter again. And there you go. Okay. Raise your hand if you were able to get that. Okay, not too bad, not too bad. Casio people, I might have you kind of group up here in a little bit, and I think I remember how to do this on the Casio, but we'll see, okay? So we'll try to get it figured out for you. So what these values are that you are given, you can kind of see the equation that they tell you. So they say y equals ax plus b. So here that value of a would be your slope, that value of b is your y-intercept. All that you are going to do then is take those values, write your equation. So y equals 2.6x, and then let's go ahead and round and say plus 65. I do want you eventually to know how to graph the data and the model. I'll just do it real quick, but don't worry about this right now. I don't want to throw too much at you at one time. But what you'll eventually be able to do is graph all of those data points along with, oh, I got to put the equation in, hello, along with your line of best fit, and you can really see that the model, the equation that we have is a pretty good fit to that data. Don't worry about that right now. We'll get to that later, okay? All right, last thing is what we call the correlation coefficient, and that is denoted by a lowercase r. And basically what the correlation coefficient tells you, as it says, is how well your equation fits the data. Okay. Your correlation coefficient can go from a +1 to a -1, where a +1 is a perfect positive correlation. When you get kind of to the middle at 0, that shows that you have really no correlation of those data points at all. And then at a -1 is a perfect negative correlation. Okay. So let's find our correlation coefficient for our example. And for some reason, the instructions to do this are not on here. So just write it down. It's not too difficult. The first button that you are going to choose says VARS. You might want to jot this down too. VARS. From there, you are going to choose option 5, which says statistics. And you see this. So VARS button, option 5. Then you are going to scroll over to where it says EQ. Hey, Castile people, don't write these directions down because these don't really apply to you. I don't want you to be like, where in the world are these buttons? And then after that button, you can see option number 7 is that lowercase r, that correlation coefficient. And we're getting a correlation coefficient of 0.995, essentially. 0.995. So what is that value telling us about how well our equation fits that data, kind of based on these numbers? Where does this fall between 1 and -1? It's really, really close to 1, isn't it? So what that tells us is that this almost perfectly fits the data. All right, last thing, guys. Thanks for hanging on. It says use your equation, and it's talking about this equation. Use your equation to estimate the height of a person with a 35-centimeter femur. So the whole point is to be able to use this model in order to find other output values. So what are your thoughts? How can we use that equation to find this height? Tell me your name. Yeah, Colin. What do you think? Okay. So let's look back at this table. Remember that femur length, those were our x values, and the corresponding heights were the y values. Allie, what do you think? Yeah, if we take that femur length of 35, that's an x value. Once we plug that into our model, it will spit out the height, okay? So then it's just a matter of taking 2.6 times 35 and then adding 65 to it, which is a nice even 156.